Hello Year 8, in this video we're going to learn how to expand single brackets by using the distributive law. Today's learning goal is to understand the distributive law and apply it to expand the single brackets. So the question may come up is, what is the distributive law? Now let's do the two examples and we will give a good definition of distributive law. So the first example, I have 4 times with 2 plus 5. You know that if I don't write anything here, but it is a little multiplication here. Okay, so 4 times 2 plus 5, we're going to use bit maths. We will work with the question, the number inside the bracket first, which is 2 plus 5. 2 plus 5 is 7, and then 4 times with the bracket, which is 4 times 7 is 28. We all know about this one. Now, instead of using bit maths, we can use distributive law by distribute the number outside of the bracket into each of the terms inside the brackets. So in this case, I'm going to distribute 4 into 2, distribute 4 into 5. And again, this is a little multiplication here. So we're going to do is get 4 and distribute to 2. It means 4 times 2. And this one is plus. So I'm going to plus 4 times 5. And 4 times 2 is 8. Plus 4 times 5 is 20, which is 28. So the two methods, whether you use bit maths or you use the distributive law, they will give you the same answers. So the definition of the distributive law is the name given to the process of expanding the brackets by distributing the number out in front of the bracket to each of the terms inside the brackets. So the distributive law is just the name of the process of expanding brackets. And here is the summary of the process of expanding bracket. First, you have to write down the expression, then expand the brackets, and finally, collect the like terms if possible. So please copy down the definition of the distributive law and the process of expanding bracket into your book. Now we're going to check out the distributive law and the process of expanding brackets by doing these examples. So I'm going to have 3 examples. The example asks you to use the distributive law to expand the following expressions. So I just copy down the process of expanding bracket into this corner so we can check it up when we do these examples. So the first example I have is 5 times with C plus 3. 5 times bracket C plus 3. So you know that there is a little multiplication here, but in algebra we do not write it. And this one is the factorized form. Now we have to expand the bracket, get rid of the bracket to bring this expression to the expanded form by using the distributive law as the request from the question. So to use the distributive law, I'm going to distribute the number in front of the brackets into each terms inside the bracket. So I'm going to get 5 times with C, which is 5C. And then I'm going to get 5 times with 3. So I just write down here 5 times C. And then because 5 is positive 5 and this one positive 3, so my next one going to be positive 5 times 3. Okay. And my final answer is 5 times C is 5C and 5 times 3 is 15. So first I write down the expression. Then I use the distributive law to expand the bracket. Next, I have to collect the like term to simplify my expanded form. So look at this one. I have 5C, I have 15. C is a term, and this one is a constant, which is a special term. They are totally different, so I cannot collect them. So this one is my final answer, and it is the expanded form. Which also in the simplest form as well. So I cannot go furthermore. So this one going to be my final answer. And remember for me, when we write like this, it is factorized form, and this one is the expanded form. Now move on to the second question. We're gonna write down the expression. So you need to write down this expression into your book. Then we're gonna use the distributive law to expand the brackets. And we know how to use distributive law after this step. So we're gonna distribute the terms or the number in front of the bracket into each number inside the brackets. Okay, so I'm gonna have x times with x. I'm gonna choose different color for the little times here, the multiplication here, otherwise we're gonna get mixed up. And then this one is negative, so I'm gonna take away x times with 4. Okay, so x times x is x squared. And x times 4 is 4x. So look, if we have any like terms, then we're going to collect the like term, which is our last step to simplify the expanded form. X squared and x are two different terms, so we cannot collect anymore. And this one going to be our final answer, right? And this one is the factorized form. Then this one is the expanded form. Now we're going to do the last example. So I have this one. First, I have to write down the expression, which is already there. And I'm going to use, next step is use the distributive law to expand the bracket. I have only one bracket, so I'm going to use the distributive law to expand that bracket only. So 5, I'm going to distribute into 4x, and 5 distribute to 2. So what I have here going to be 5 times 2, 4x, and then plus with 5 times 2. And then I rewrite these down because there's no bracket, so just keep it there. So take away 7x and plus 6 stay the same. Now I'm going to bring it to the simplest form by multiplying these first to see what we have. So 5 times 4x is 20x, and plus with 5 times 2 is 10. Write down 7x and 6 there. So step 1, write down the expression. I did that. Step 2, use distributive law to expand the bracket. I did that already. And now step 3 is collect like terms. So I have to identify the like terms in here. So we have 20x and negative 7x. They are like terms. We also have 10 and 6. Positive 10 and positive 6 are constant. So we're going to rearrange the expression so the like terms can stand next to each other. So it's going to be 20x grouped with 7x, negative 7x. When you rearrange the terms, you have to bring the sign in front of the term with it. Okay, so 20x grouped with negative 7x, and then 10, positive 10 grouped with positive 6. Positive 10 group with positive 6. And then you're going to collect like terms. So D2, 20x, take away 7x is 13x. And these two together is going to be 16. And this one is your final answer because we don't have any more like terms. And it's also the expanded form of this one, the simplest expanded form of the expression here.